Okay, today we are going to be looking at powers, or indices, as they're also known. What do we mean by powers and indices? Well, essentially, and you've probably seen these before, it means when we write a number such as 3 and we raise it to a power, we write a little number up here, which is our power or our index, and that is 3 squared. It means 3 to the power of 2. What does that mean? Well, we look over here, I have a square, and because we're dealing with square numbers, it helps to think about what that means in terms of a square. Because a square number essentially means what is the area of this shape. If the side length of this shape was 3, side length here is 3, the area of that shape, we know, being a square, with all 4 sides the same, the area is going to be 3 times 3 times 3, which equals 9. Not putting any units in here for now, it's just thinking about the numbers. So 3 squared, it just means take the number 3, multiply it by itself, it equals 9. So let's think about some different square numbers. Exactly the same process. If the side length of our square was now a little larger, it's 4, the area of that square is going to be known as 4 squared. Just the same, that means 4 times by 4, which equals 16. Okay, and on we go. Working up through our numbers. I'm not going to do all of them, but perhaps let's have a look at 1 to 10. 5 squared is going to be 5 times by 5, which equals 25. 6 squared, 6 times by 6 equals 36. And what we are producing here is a sequence of square numbers. These are referred to as square numbers. 7 squared, just the same, equals 7 times 7 equals 49. 8 squared, the area of a square, side length 8 equals 8 times 8, 64. 9 squared. So we're testing the times tables with square numbers. 9 squared, 9 times 9, of course, is 81. And then we go up to 10 squared, a side length of 10. The area is 10 times 10. Fill that in again, which takes us up to 100, our first 3-digit square number. The one I missed out at the start here, 2 squared, just to complete that sequence, 2 times 2 equals 4. So there's our square numbers, up to 100, up to 10 squared. In GCSE terms, there is an expectation that you will know these square numbers, and you will know square numbers slightly beyond this as well. Certainly to 12 and perhaps beyond that to 15. But it is very useful to be able to work them out, particularly the larger ones, if you're not able to instantly recall them. So if you were asked for example, 12 squared, we know that we're looking for the area of a square, side length of 12. So it's going to be 12 times by 12. And let's say we don't know this one. Most of them you need to remember. But if you don't remember them, you need to know how to work them out. So 12 times 12. Well, there are lots of ways to work that out. I'm going to use a grid method here. Grid method for multiplication. We're going to say 12, which we're going to break down into the tens and the units, a 10 and a 2. And we're multiplying that by 12, which is, again, a 10 and a 2. So what do we get? 10 times by 10, 100. 10 times by 2, 20. 2 times by 10, 20. 2 times by 2 is 4. Let's add up our 4 numbers that we've just worked out. 100 plus 20 plus 20 plus 4 equals 144. 12 squared, 144. And that's how we work out square numbers. And finally, just to leave you with a little bit of algebra, if we were to think of this in terms of a side length L, so we no longer know what this side length is, we're going to call it L, just means the length of a side. Being a square, of course, that means that this is also L. So in terms of algebra, we would write that L squared to get the area of this square equals L times by L. Okay.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.